subject oriented. Why it is called as a subject oriented system when you do that? So when we talk about a subject oriented, basically in the data warehouse we design the tables according to the each subject area. In the sense, if I am storing the data for a sales, I'll define a separate tables. If I'm storing the data for marketing, I'll define a separate tables. If I'm storing the data for finance, I'll create a separate tables. So here the data is categorized. Here the data is categorized according to the topic, or you can call it as according to the subject area. That's why it is called as a subject oriented system. What do you mean by subject area? It could be sales is one department in your organization, can be called as a subject area, or it could be marketing, that is one subject area, or it's a finance, which is also a subject area, what we call that is called as a subject oriented system. And when we talk about an integrated, so what do you mean by an integrated? So integration means if you are pulling the data from multiple things, that's called as an integrated. So why do we call a data warehouse as an integrated system? Is that you're actually integrating the data from multiple sources, right? So it is not that one single source data we are integrating here. From the multiple sources, you are integrating the data into a data warehouse. So that is one reason why we call a data warehouse as an integrated system. And another reason is that if you look at the multiple sources, these multiple sources are not same, right? It are heterogeneous in nature. So you're integrating the data from the diverse sources. That is also another reason why we are integrating the data from the why we call it as an integrated. And it is also that we are also integrating the data from the diverse formats of the data. When you say diverse formats, what do you mean by diverse format? Let's say the data is available in the form of a data could be available in the form of a flat file, or data could be available in the form of a relational tables. It could be in the any format. So here it is present in the relational format, and I can also integrate the data from flat files, and I can also integrate the data from XML files. Anything could be there. So this type of data integration, which is also called as a diverse formats of the data, what you see, multiple sources, diverse sources, and the diverse formats. That's why the data warehouse is said to be a integrated system. Okay. So the next one is about the time variant. So when we talk about the time variant is about, the basically the data warehouse will store the historical data. We understand that it is historical in nature. When you say time variant, data can be accessed for any time period. Data can be accessed for any time period. In the sense, let's say if I want to know the basically if I want to know the data for 2015 quarter 2, I can understand. If I want to know the entire profit for a 2014 year, I can get. So data is available for all the time periods. That's why we call the data as a data warehouse as a time variant system, what you see. What do you mean by non volatile? Volatile means which changes very frequently, that is called as a volatile. Non volatile means data in a data warehouse does not changes very frequently. Once we load the data, we are going to use them uh, for years to analyze the data. So data is not changed very frequently. That's why data is not modified frequently. That's why we call the data warehouse as a non-volatile system. So data warehouse will have all these characteristics, which is used for a decision making. This is a definition given by your Bill Lemon. Bill Lemon is a scientist who has actually given up this. Given this idea to this. And another one is like a Kimball. There is another scientist who has actually carried out his thoughts into the wide scale. Another scientist is called as a Kimball. So Ralph Kimball. So you might see a lot of blogs on a Kimball's name. Ralph Kimball is basically, how he defines the data warehouse as a. He defines the data warehouse as a historical transactional snapshot. Historical transactional snapshot. So it's basically what he says is that you're actually reading all the transactional data and storing it into a warehouse in the history of transactions you're storing. That's why he defines the data warehouse as a historical transactional snapshot. So this is a standard definitions given by your two scientists who are Billy Mann and the Ralph Kimball. See, from this diagram, we understand that we are integrating the transactional data and the data which is in the form of flat files and XML files into your data warehouse, which is nothing but a database. So, which could be your Teradata or Oracle, any database can be your data warehouse. So, why do we do, I mean, what do we do by loading the data into the data warehouse? It is basically used for a analysis. So, what kind of analysis that you do? What kind of analysis that we do? I'll come back to that question. But how you do analyze the data? How do you analyze the data? So, data can be analyzed with the help of a BI tools. So, BI tools or the reporting tools, what it does is it will read the data from your data warehouse and show it to the business user in the form of a beautiful visualization charts. So, the process of analyzing the process of generating the reports and generating the visualization charts is called as a BI. So when you look at the BI, so this is your pie chart, let's say bar graph, and if you have it as a, let's say, any other format, it can be represented in a tabular format or a line graph format, whatever it is there. In this you can assign the BI. So basically all these BI tools will help you to generate the reports from your data warehouse. So it is just that your BI tools will read the data and show it to the user. That's it. Doesn't do anything else. Now, what is the job of ETL here? ETL will extract the data from all these transactional system and load it into the data warehouse. So now we understand the two terms, what is an ETL and what is a BI. So let's understand few things here. See, we are all integrating the data from the transactional system into the data warehouse. It is just for analyzing the data, nothing else. You're not doing anything else with the data warehouse. Why should we load the data from all these transactional system into the data warehouse? Why can't we start analyzing the data on the transactional system itself? Why can't I use my reporting tool here which points to this Oracle database and generate the report and show it to me? Why should we only create a data warehouse? Yes. So let's understand the differences now. Why not OLTP? In the sense, why can't I use an OLTP system for a analysis? So basically, there are disadvantages which is carries. When you see, there are different disadvantages with your transactional system, which cannot be used for a analysis purpose. So basically, first thing is that in the transactional system, no history will be there. So if I take a look at my ATM withdrawal, if I go and take a mini statement, probably I have only hardly 5 or 6 transactions which I have. I don't have a, sorry. So I don't have the historical transactions which are there. But when it comes to the analysis, we'll always look for a historical data. In the sense, I want to always compare what was my last year revenue versus current year revenue, or last year growth versus current year growth. So always will compare with the historical data. If the historical data is not there, I can't use in my OLTP system. And also, the second thing is that your OLTP system is more normalized in nature. It is more normalized in nature. Most of the time, it is normalized up to third normal form. Okay. So what do you mean by normalization? What do you mean by the normalization here when you do that? Let's say normalization is basically the process of organizing the data in different tables, process of organizing the process of organizing the data in different tables to eliminate the duplicate records. To eliminate the duplicate records, that is called as a normalization. See, normalization has a different forms. It's actually it consists, it carries the different rules which you have to apply to organize the data in different tables. We'll understand about this, but basically the normalization is more like a different forms: 1NF, first normal form, second normal form, third normal form, and you have another one called as a 3.5NF, and then the fourth normal form. So each normal form carries the different rules, and if you apply those rules, it will help you to eliminate the duplicate records across the tables whatever you design. So what is the disadvantage? Why normalization is disadvantage for a reporting? Basically, one thumb rule that you have to remember is that more you normalize the data, more number of tables will be present. So degree of normalization is directly proportional to the number of tables. So more tables, more normalization will result in a more number of tables. Why more number of tables is disadvantage for a reporting? Why not? It is disadvantageous if I am distributing the data in more number of tables. So basically, when you want to read the data, right, so you need more number of joins. So if you have to read the data from 10 tables, you need 9 joins. Similarly, if you want to read the data from 3 tables, it is easy. See, what I'm trying to say here is it's always easy to read the data from less number of tables than reading the data from the high number of tables. Okay, so more number of tables means more complex queries you have to write, more complex joins, and the complex queries which we have to use for writing the data. So this is a disadvantage with your OLTP system, because I have a more number of tables. Obviously, when I try to use that, I have to write a complex queries, and moreover, if I'm writing my complex queries, it will also impact the performance of my transactional system as well. This will also be done. That is the another the disadvantage with your OLTP system. And the data is also distributed across the multiple system, so it is a time consuming process for analysis. It's a time consuming process for analysis which you see. So when you say time consuming process for analysis, basically um, what will happen is that if my transactional data is distributed across the multiple systems, if I have to analyze the data, I need to analyze the data in this transactional system, and this system, and which is a time consuming process. I have to find out the, suppose let's say across all the line of businesses, I want to understand the profit. First, I need to generate one report here, another report here, another report here to understand the global profit or a complete profit. So, which is like a time consuming process, and it takes a long time, for a business user to understand what is the profit across the business. Suppose if I am integrating all the data into one single data warehouse, it gives me the flexibility to analyze the data at a faster pace and a rapid pace. So this is about the disadvantages of the transactional system. That's why we are not using the transactional systems for a reporting, and this is the reason why we are building a separate system just for an analysis, so that all these disadvantages will overcome by your data warehouse what you're building. So when you say no history, we will actually design the tables in the data warehouse to store the historical data. When I'm designing a tables, I'll make sure that my history is being captured in my data warehouse. So this disadvantage is overcome. And when I'm actually not, storing the data, I always normalize the data warehouse to second normal form. Means if I less normalize, less number of tables will be present. So less number of tables are always easy for a reporting. So that is another advantage that you get. So here it is third normal form, means in the data warehouse we'll go for a second normal form only. So it is not a time consuming process because entire data is available in one single centralized place. it is easy for me to do the reporting. So this is the differences between why can't we use an OLTP system, why we are separately going for a data warehouse. So let's take a look at the simple differences between your transactional system and your data warehouse, how it will work. So basically, this is just to help you to understand the different characteristics of the transactional system and the analytical system. When we take a look at the OLTP, it is actually used for a day-to-day operational and the transaction purpose, not for the analysis purpose. When you look at the OLTP, it is more used for analysis purpose. Now, when we talk about the OLTP system, who is going to use that application? See, basically, when you talk about a ATM withdrawal, customers can use, whoever is your bank customers, they will use it. Or when you go to the banking system, they will be depositing all the money and everything. So that will be used by the bank clerks and everybody. So the application, when you talk about the transactional application, it is not used by your business users. It is used by the either the bank clerks or the low level employees. And then they will use. And when you look at your OLAP, it is actually used by the knowledge workers. When I say knowledge workers, it is used by the CEO, COO, sales managers, marketing managers, finance managers. All these guys will use it. And the number of users who uses the OLTP will be more, and the number of users who uses the OLAP will be very less, because high level business users will be that. And we also already understand it is used for a day-to-day operations, and this is used for a decision making, for analyzing the data. And when you look at the OLTP, we'll have a data at the lowest granular level. Lowest granular level means, suppose let's say in my transactional system, if you go, let's say if you take an ATM withdrawal system, uh, suppose as a customer, if you're performing 10 transactions in a day, all your 10 transactions, at what time you have done, how much amount you have withdrawn, everything will be stored. Okay, 10 transaction means I'll have a 10 records in my transaction table. If I look at, when I say it is an aggregated data, or the summarized data, what will happen is that when you are storing the data into the OLAP, let's say I don't want to store the each and individual transaction performed by the customer. I want to store how much money this customer has withdrawn in one day. So you'll have only one record for all these transactions. Basically, all these 10 transactions will be clubbed in as one aggregated value, and then it will be stored. So when you say that in your transactional system, it is at the more detailed level or more granular level. When you look at your OLAP, it is at the higher granular level. Higher means it's an aggregated value. So instead of having 10 records, I'll say that customer 100, today he withdrawn 10,000. That's it. So that's how we represent it. That when you have withdrawn, what is the amount, that information will not be present in the warehouse. We'll aggregate it and then store. And another information, yeah, we understand that OLTP will not store the historical data. It will always store only the most recent data, and another is your historical data, what we have. So this is more like an application oriented, and this is a subject oriented. I told you what is mean by a subject oriented and all. So here, in case of a OLTP system, both read and write both will happen. In the sense, customers whenever they want to see what and all of the products are there in an e-commerce application, you will read the data, right? So when you go and search it, your application will read the data from the transactional system and show it to you all the products. When you say write, what does that mean? When you book a product, you're writing an order into the system. So both read and write operation will be performed. But in case of a OLAP system, it is once the data is loaded, it's only the reading will happen, only the read. So that's how we will define it in this. And when you talk about the OLTP system, we know that all the transactionals will flow into the transactional system. And the next one is about the here this will help you to do that. And the number of rows in the transactional system will be less because it doesn't store the historical data, and this will be in millions because each and every day you're going to append the transactions to the this one. So this is about the different records what we have. And the number of users who uses will be very high, as I said, and this will be very less. And number of records in the transactional system is directly proportional to the size, right? If you have a less number of records, less memory will be occupied. If you have more number of records, more memory. So basically you have millions and millions of records. That's why your data warehouse size will be in terabytes, and whereas your transactional system maximum, it will be in the gigabytes, not like this one. And this should be like a high performance and highly available, and this should be like a highly flexible application. I mean, for the your end business user, it should be very easy for a reporting when you define a OLAP. And the performance of a transactional system will be measured by using a transaction throughput, and this will measure it as a query throughput. That means when we say the performance, how much time it is taking for each transaction, that is a metric of for a performance. But when you look at the OLAP system, it is basically used for a query throughput, means how much time it is taking for me to generate a report. That's what we say. So these are the simple differences between the transactional system and the data warehouse. So basically why we are saying is OLTP cannot be used for reporting. It is can be used only for a transactional purpose, right? So let's understand these questions, and I'll take up your questions on that. Okay, now when you look at the see all the time during the demo class as well as now, we are understanding it just the used for analysis. When you say analysis, how a data warehouse can help the business users, that is the main thing that you have to understand. When you say that you're building a data warehouse, for what purpose you're building the data warehouse and how it is used by your business users, that is the main question that you need to understand. See, is data warehouse is specific to a particular domain? No, it is for every domain. So data warehouse is for a telecom domain, and data warehouse is for a financial domain, data warehouse is for insurance, and data warehouse is for a retail. Every domain you need a data warehouse. Okay, so BI itself is very important for any business to run. Okay, when we talk about that, let's say let's take one specific industry and understand how a data warehouse can help them. So let's take the Vodafone as your Vodafone is a telecom client, right? So how does a data warehouse will help them to understand? Let's say Vodafone is actually receiving the, I'm just trying to give you one scenario. Okay, Vodafone is receiving the calls from the one of the East Bangalore. They're receiving calls every day saying that network is not proper and everything. So if they are analyzing that information, if they are analyzing that number of customers who are calling and for what reason they are calling, so if they understand that information, that okay, this many people are actually calling us for a issue, and what will help them is to understand is that if they understand in a proper way that so there is a problem with the network, if you're actually taking a decision to build a proper network in East Bangalore, probably you can retain all your customers, right? So unless they take that decision, it is not possible for the customers, it is not possible for them to retain, right? So basically, unless they know that people are calling for this reason from this region, they'll not be able to take a decision. So here a data warehouse will help you to understand that kind of a problem. So that is one reason. In a way, how does it helps your business? You're able to reduce the number of calls handled by your customer system, right? The number of calls will be made as a less, and your service is also improved. That is the return of investment for you on that. So the number of calls is reduced, what you have to handle every day, and the service is also improved and your customer is happy. That is called as an analysis. You're able to understand the customer requirement and take a decision very quickly. And when we talk about, let's take a retail as an e-commerce system. See, unless the e-commerce system knows that which products they are not able to make a big impact, they'll not be able to take a decision of discontinuing that products. So let's say they're selling wide variety of products, As a sales manager, you're always interested in understanding the top 10 selling products, bottom 10 selling products, or which are not generating a revenue and all. So what is the advantage of identifying that? So why do you need them? So basically, if I'm able to understand that, okay, Samsung products are not making big impact, and now, so then what do you do that? You basically take a decision of not promoting those products anymore. So you'll not promote them, and in a way that you'll reduce your marketing costs and you'll concentrate on some other products which can give you the better revenue, right? So that's how you take a decision and then do it. So that is for a retail industry. Or retail people always wanted to understand, they'll always compare a city to city growth of the business or sales of the business. Let's say, as a operational manager, I'm interested to understand how much revenue that I'm generating from Bangalore, how much revenue that I'm generating from Chennai. So if I understand that basically Chennai is doing good and Bangalore is not doing good, what a decision that you take, you basically take an extra steps to improve your sales strategy and to promote your products more better, and then to improve the business. So basically, these are all the decisions which, on a day-to-day basis, as a business user, you need to take and promote your business. Take a very quick decisions and apply according to the market. Okay. Otherwise, you'll not be able to make a big impact over your competitors. So every business is a competitive business. So unless you analyze your data every day, unless you take a decisions very quickly, you'll not be able to succeed in your business. So that's why a BI plays a very, very important role in any business. So if you even think why data warehouse consultants and all are very high in demand, or this is because your revenue from the, if you take a complete software revenues, 51% is actually generated from only from the BI. Only from the BI, 51% of the entire software revenue is generated. So you can see the power of BI. So when you say that, it is so important for any business, even for a very small scale business also, it is so important that they have to understand and analyze the data every day on a day to day basis. So that is why, if you see, even let's take some more example. Okay, if I want to understand the profitable customers and non-profitable customers, so what is the need of identifying profitable and non-profitable customers? Basically, when you are providing an offers and all, right, so you'll go and provide offers to the profitable customers, not to the non-profitable guys. Let's say you have got the Vodafone sim and you're not using from past 2 years, and Vodafone will not come and give you the offer saying that we'll give you the postpaid connection for free. They'll not say that. They'll actually analyze in the back end, they'll analyze that who are the customers, who are our potential customers, to convert them into the postpaid. So that's why you often receive the call saying that, okay, your monthly usage is more than 800, would you like to go for a postpaid? So all these kind of analysis, how they do, they analyze the data and then come back to you with the statistics. Okay, so that is another one why we do that. And there is another question like, what is a defaulters profile? Let's say you are actually providing a credit cards. Okay, so as a credit card manager for a particular bank, it's your goal is that, am I recovering my money passed from the customers or not? Okay, so suppose, let's say there might be customers who have not paid the credit card bills from the past 3 months or 4 months, and who are not actually responding and all. So you quickly have to get the money from them, unless otherwise the liquidity will impact in your business, right? So unless you know that who are the defaulters, you'll not be able to take any action. So that is another way how your data warehouse can answer your question. And when you talk about the revenue, so most of the CEOs and all, they are more interested in understanding how our revenue is improving. At the end of the day, it is a return of investment for you. I mean, it's the revenue that matters, right? So when you talk about that, let's say, what is the total revenue this year and what is the revenue next year? So we'll always compare it. So how the revenue is improving from past 5 years, whether we are going down or going up. So according to that, we need to analyze and then do it. So, and the data warehouse is also for every department in your organization. It is not only for a sales guys. It is not only for your marketing guys. It is not only for your finance guys. It's for every department. You need a data warehouse to understand. Even a data warehouse is required for bigger organizations like a TCS and Cognizant as well. Why do you need a data warehouse for them? See, unless you understand your employees' pulse, you'll not be able to take up policies and come up with the right policies and all, right? So basically, if you want to understand what is my attrition rate from past, attrition rate, so the number of people who are leaving the company and going, so what is my attrition rate from last month to this month, or last year to this year, whether I am able to retain my talent or not, you need to analyze that. Otherwise you'll not be able to make an impact, you're going to lose your talent. And what is your growth in your pay scale for your employees, how actually planning the increments, and based on your budgets and everything, can I offer an increment of 10% for all of these employees? If I offer a 10%, how much impact it is going to make, or how much revenue, or how much liquidity that I have to pump into my business? So all these things, or what is my employees utilization? See, I'm taking an employee, and how many people are on bench from past 2 years? I want to understand why they are on bench. So you need to, unless you know that that bench strength is there, you'll not be able to take a decision and then move forward, right? So every business depends upon reports on a day-to-day basis. If you have to continue the tomorrow's task, you need to understand what is today's status and then go to the next status. So that's the impact of BI in your business life. So it's for everybody, so it is not only for HRMS, sales, marketing, finance, customer care executives. For everybody it is required. So this is how your business, your BI system can answer all these type of questions. That's why if when you see a data warehousing projects, it's for every domain, whatever you can think of, it's for every domain you'll have a data warehouse project. So that is where data warehouse will give you the better advantage over your competitors. Okay, so it's always the return of investment. See, building a data warehouse is not so easy, it's a cost oriented process. Okay, you might have to invest some $2 million or $3 million just for building a data warehouse. Why people are ready to do that? Because if they invest that much amount of money, they can increase their business to $10 million or a $10 billion. So return of investment is always there, so that's why they invest the money and then do that. And when you are building a data warehouse also, you should always look for what is my ROI. If I'm spending this much, what is my return of investment? Am I expected to increase my data, revenue or not? That you need to also analyze and then understand with respect to the queries, right? So this is the thing, that what we understand is what is a data warehouse and what is a difference between a transactional system and the OLAP, and what kind of questions that can be answered by your data warehouse. All right, any questions so far? Yeah, you guys are on the mute, online people who have joined, and you can unmute yourself and go ahead with your question in case if you have any. So if you have any questions related to the training, I'll answer that questions later. Okay. Okay. All right. So next, yeah. View. That's what I told, right? It's a detailed relational table, lowest granularity, 10 transactions, and this is an aggregated data you'll have for only one transaction for one customer. I said this, right? So as a, hmm? Detailed means it's at the lowest level. So now when I said that customer, as a customer you're performing 10 transactions, all 10 transactions is being stored in a table. That means that the detailed view of the data. When I say that it is an aggregated data and stored in your data warehouse, that means you're aggregating for one customer how much this customer has withdrawn this much amount of that you're saying. When I look at this data, customer 100 has withdrawn 10,000. Will you be able to understand how many transactions he performed? Will not be there. But in the relational table, in the OLTP, I can understand at what time what is a transaction that is being done. That's the meaning of that. Okay, So why it is relational in nature is because I mean your OLTP itself is relational in nature because there will be different relationships. That's why it is more like a relational in nature. Okay. So now let's move on to the next one. That is your architecture of the data warehouse. So how do you build the architecture and how do we do the this one, which is the architecture of the data warehouse when you do that? See, basically, yes, I said it is denormalized. It's set up to second normal form, I said, right? In the OLTP, you have a third normal form, and then I said it is second normal form. When I listed down all these things, I did say that all these disadvantages will be overcome. All right. So when we talk about the a data warehousing architecture, basically it's very simple for us to understand. I mean, when we say here we are reading the data and loading into the data warehouse, but data warehouse is actually divided into multiple phases. We don't directly read the data from your transactional system and load it into a data warehouse. Okay. So how it is going to work in case of this architecture is that we'll have a multiple phases before we load the data. One is called as a staging area or a staging database, and another is called as a ODS or operational data store. Operational data store, and the next one is called as a enterprise data warehouse. Enterprise data warehouse, or not enterprise data warehouse, let's call it as a data warehouse. Okay. Data warehouse, and the another component that you have in the data warehouse is a data mart. So these are all the different components of a data warehouse. We'll understand what is the use of this, each and everything. See, when we talk about the uh, all these areas, these are the a group of physical tables which exist in a particular database. So when I say staging database or a ODS database or a data warehouse, it's nothing but the group of physical tables, a group of physical tables which will be present in each area. You'll have a separate staging tables, you'll have a separate ODS tables, you'll have a separate data warehousing tables, and you'll have a separate data mart tables as well when you do that. So let's try to understand the uh, this one, the transactional system. Let's say we have, and I have a different transactional systems here, and we know that there will be a transactional system means there will be a frequent transactions which will be happening on a day-to-day basis. Okay, and it could be any transactional system, whether it could be your financial system, and whether it could be an HRMS, okay, or it could be your CRM application, anything. Or let's say this is what we have a different thing. So what we do is before we load the data into the data warehouse, first we will extract the incremental data from your transactional system and put that incremental data into a one temporary database called as a staging database. So when I say this staging area or the staging database, it's the group of temporary tables is called as a staging area. See, when I say staging area, is it a part of your ETL process? No, it's the physical database which exists. I'll have a separate database which will store only the incremental data. I'll come back to that term incremental data. So whenever we say this is of a group of temporary tables, always these tables will hold raw data. Raw data means a data which is not transformed, that is called as a raw data. Okay, and always the staging area tables are truncated and load. So we are going to truncate them and load the fresh data into the staging tables. Okay, so you're saying that you'll extract the incremental data. How do you move the data from this transactional system into a staging area? Basically, this is moved with the help of a ETL tools. So you can use any ETL tool. Okay, so we'll use, let's say, Informatica Powercenter and move the data from all these transactional system and put it into the staging area. So what do you mean by an incremental data? So this is a very important term that you have to understand. Okay, incremental data means, so let's take an example and understand, or it can be even called as a CDC as well, change data capture. Suppose, let's say, you are actually have the data like January 2015, January 10 2015, and I have a table called as a order table. Okay, in the order table, assume that I have a 10k records, 10,000 records which I have. So when I run the ETL load and load the data into the my staging table, I'll actually extract all the 10,000 records using an ETL process and load it into the staging table. And from staging table it will go to ODS and the fact. Okay, just assume that. Let's say you are moving the data from the OLTP system to the staging area on a weekly basis or a daily basis. Let's understand. It depends upon the business requirement. Okay, so whether we'll do a daily or a weekly what we have. So when we take a look at the this one, uh, let's say if I'm running a load on January 17th 2015. Okay, so it could be that in your order table there might be 2k new orders would have been created, 2000 new orders have been created, and let's say some of the existing orders also might have been modified, means customers might have cancelled the order or they might have replaced that with a different product as well, all those things. Let's say some 1k records which are being modified. When you run the load on January 17th, so we are interested in extracting the data which is added and modified, not the entire data what is available in your data, in your transactional system. So if I'm extracting only these 3k records which are added or modified, this is called as an incremental data. So whenever you are running a load, we are always interested in fetching the incremental data and loading into the staging area. At any point of time, if you look into any staging table, it will always have only the incremental data. Okay, so that incremental data will be put it into this. Let's say when we talk about this, and when you run that on this that time, we'll always truncate the existing data. That means we'll remove the existing data and load the 3k records which are being there into the staging table. Now when we talk about this as a raw data, why we are calling is because when I'm using an ETL process, I'm not transforming it, I'm just extracting and dumping it, no transformation logic. That's why we call this as a raw data. Okay, now the data is available in the form of, let's say you have a customer table here, and let's say you have an employee table here which is there in HRMS, and you have, let's say you have something like a lead table, s underscore lead or something. Okay, or contact. Okay, so I'll take up your question. I'll take up your questions. Okay, when you see this transactional systems, for each and every table you'll have a corresponding staging table. Okay, so we'll have a corresponding staging tables like stg underscore customer, and let's say you'll have another one called as a stg underscore employee, let's say stg underscore s underscore lead or something like this. For each and every table we'll extract the transactional data and put it into the staging area, and this transactional data is being done with the help of a ETL tools. We'll put it into the staging area. Yes, what is it? Okay, okay, I'm repeating what is incremental data. Okay, So you know about that a transactional system means there will be a new transactions happens, right? You know what do you mean by transaction? You understand, right? What do you mean by a transaction? Okay. Now, suppose let's say when I'm this is the picture of order table in my transactional system on January 10th, 2015. Okay. In January 10th, 2015, in my order table, I have 10,000 records, means 10,000 rows I have in my order table. Okay. So I'm reading all those 10,000 records and loading it to the staging table. That staging table is nothing but a which is there as part of my staging area. Okay. So let's consider even that as a stg underscore order. I have loaded that data. Now in the staging table, how many records you have? 10,000 records. Okay. Now, what I said, the data movement from the transactional system to the staging area may happen according to the business requirement, whether it is on a daily basis or a weekly basis. Assume that we are loading the data on a weekly basis, right? When I again go and extract the data from January 17, 2015, by that time, during that 1 week period is there, no? There is a 1 week gap between your last extraction and today's extraction. When you do that, the new orders would have been created here, right? So let's say new orders would have been 2K records. And it could be the case that out of these 10,000 records which were present before, some people might have cancelled the order. They might not be interested in that order because the delivery is delayed, or they might have changed their mind and then dropped the plan and going for a new product. They might have cancelled that order. So when you cancel that order, so how many records? This 1K records are the not the new set of the orders. It is the existing orders which has been cancelled or which are being modified. So how much data is modified now from January 10th to 17th? 1K is modified. What is the total set of new records then? Hmm. Hmm. Okay. Total records how many? Yeah, 12K will be there in the order table. So now, are you interested in fetching all the 12K records, or is it okay that if we can fetch only these 3K records, that is enough for us? Why 3K? Oh. Now total 12K records are there. So would you say when you design an ETL process, is your ETL process you're expecting it to bring in 12K records again, or 2K records, 3K records is enough? Now total number itself is you have 12. Total number is 12K only in that. So I said this 1K record is modified data. What do you mean by modified? You're going and updating a record. It is not a new record which is coming and sitting in your table. It is 1K record which is being modified. Okay. So now I'm asking you the question, when you design an ETL process, if your ETL process has to bring all these 12,000 records which are present in your order table, or you're interested in fetching only the modified data, that is 2K plus 1K, 3K records, modified data, right? So now you're fetching these 3K records. These 3K records are called as an incremental data. The 3K set of records, whatever is being, okay, let's put the definition in this way. When you say an incremental data or a CDC, the data which is added or modified in your transactional system after your last extraction is called as an incremental data. You understand my term? Okay. Yes, it is going to be removed. Before that, I said one more term also. I think you missed that. So from the staging table, I said it will go to the ODS, and from ODS table, it will go to the fact table called as an order item fact or something. I said that. So the data from your staging table further will be processed by the different processes. So we didn't even complete that. So still there are lot more has to flow from data till the data reaches data warehouse. Okay, so that's why just hang on, I'll answer all your questions at a time. Now you have the staging area here. Now the staging area holds the incremental data, and it's every day whenever you load the data into staging area, it will be truncate and load. Okay, you'll remove and then do it. Then from the staging area, again we'll define a separate ETL processes. It is not the same ETL process or a same ETL program. We'll define a separate ETL program, and this ETL program, what it does is it will read the data from your staging area or a staging database and load the data into another database called as a ODS, which is called as a operational data store, what you see. So it will be stored into the operational data store. Operational data store is also another database which has the different tables. It's like you have tables like ODS customer and ODS underscore employee and ODS underscore order, what we have, and let's say these are all the, let's say, ODS underscore lead, different kind of or ODS underscore contact, different kind of a tables which will be available. So when we are defining an ETL process here, we'll actually transform the data. What do you mean by transformation? It is nothing but the data transformation. So when you talk about the data transformation, which means the modifying the data from one form to the other form, or applying the business rules, applying the business validations, this is called as a data transformation. Applying the modifying the data from one form to the other form, data from one form to the other, which it is there, data transformation and all what we have. So this is your operational data store, what we have. So data transformation means when we are moving the data, we'll apply all the business validations, all those things, and load the data into an operational data store. And another type of a technique which we also follow, that is called as a DC. DC stands for a data cleansing. So what do you mean by the data cleansing is, so basically the data cleansing is called as a process of cleaning the data, process of cleaning the data, or process of removing the errors, process of removing the errors, duplicates, all these things, errors, duplicates, all these information, that is called as a data cleansing. So when you are defining an ETL program here, we'll apply all the transformation techniques, cleansing techniques, and then load the data into your operational data store. See, in your operational data store, you'll have a data for more than 2 years, 3 years, likewise. It'll be keep on appending. We don't remove and load like a staging area. It'll be an appending mode. Means we'll go and add a new records to that. Whenever there is a new record, we'll go and add that into that. So this data will be there for 3 years or 4 years. It depends upon the design. So most of the cases it will be for 3 years like that. We'll design a operational data store when you do that. So now let's say this is data which flown, and now from the operational data store further we'll load the data into another database called as a data warehouse, which is called as a enterprise data warehouse. I call it as a data warehouse, not okay, let's not call it as a data warehouse. We'll define another ETL process, we'll define another ETL process which will move the data from your operational data store, and this data will be aggregated means calculated at the higher grain, like a total sales, average sales, all these kind of an aggregated, and summarized data will be loaded into your data warehouse. It's like here in a data warehouse you'll separate the data according to the dimensions and the facts. Like here you can have something called as a dim rep, dim underscore customer, and let's say we have another one like a dim underscore vendor and order item fact. Likewise, we'll have a different tables where your data will be separated as a data will be separated into the dimension tables and the fact tables which it is there. Now a complete data is actually flown from an operational data store to the data warehouse. So at each and every stage we'll define an ETL process and then load. So data warehouse is actually defined as it's a data for all the subject areas for a sales, marketing, and everything you are combining and then storing. And further from the data warehouse, we will again load the data into a different set of individual data marts which are defined for a specific subject area. So data mart is nothing but the you can call it as a subset of the data warehouse which is defined for a specific subject area. So this may be all the sales related table we can have it here, and marketing related table we can have it here, and this is your data mart what we have. So when we look at the this one, so data mart is called as a subset of the data warehouse designed for a specific subject area which we have, that is called as a data mart what you use. So this is how we can uh, this is how your data will flow, and finally once you load the data into data warehouse, your analysis will be done from the all the type of this one. So let's say you have a BI, so this is your business intelligence, and when you do that your data will be loaded from, I mean your data will be analyzed from this and then this as well. So likewise your BI reports will be set up, will be generate the reports from all these different data marts and the data warehouses. It depends upon the architecture to architecture. It is not that all the architectures whatever we are designing in a real time will have a data marts. It's a kind of an optional one. You can have a data mart, or you can directly do the reporting from a data warehouse as well. So that also depends. When you talk about this operational data store, is it mandatory that we have to build an operational data store, or we can load the data from staging area directly to the data warehouse? Yes, it can be done, but this operational data store is more used for a operational purpose. It's like, I'll give you one example. We are saying that let's say you have a banking system. In the banking system we are saying that we don't have a historical data and it doesn't store it, maybe 10 transactions and all it will store. But when you go to the bank, they'll give you the historical statement for 5 years also, right? Or 3 years, 6 years also they'll give. But why, when there is no data here, how they're able to get that? Basically they will maintain a separate database which is like an operational data store. In that operational data store they will maintain all the historical transactions whatever you have made. When you go and ask them, they'll generate a report from the operational data store, and then so when you say that, is it used for analysis? No, it is used for your operational purpose. In order to help your business operations, you're actually using a operational data store and then doing it. Now when you talk about this operational data store, what I'm trying to say is that it is not used for analysis. We don't analyze the data on top of this. It is used more for operational uses. Even it might be used by your bank managers or a bank clerks, whoever is there, they will actually generate and give you. They're not actually a business users. They're just employees, like employees in a bank might be using it. So this is how the data flows from your transactional system to the data warehouse for a complete process. Okay, so when you talk about the staging area, operational data warehouse and all, it's a separate physical databases. So the way how we are saying that as a Oracle database can be treated as a data warehouse, here also we'll have a separate database that is called as a operational data store which could be created in Oracle, and staging area also, which could be there in the Oracle database. That's how your data flow will work from the transactional system to the complete data warehouse, right? Okay. Any questions on this now? It is not a, it's a separate database altogether. You can define a data mart into a separate database, or you can just build on top of a data warehouse. It just you can call it as a group of tables. Data mart is like a group of tables, but it is not a staging area. It's not a staging area. So it could be that you can do even a full load as well from here to here, right? So this is how we'll uh, define the data warehouse. So we have a different architectures which are there. So that we will discuss it tomorrow. What are the different architectures that are available, and what is the difference between a top-down and bottom-up approach? And from there, we'll move on to the next one, that is your data modeling in the tomorrow's class. So today's class we covered till this. I mean data mart and all those. Tomorrow we'll understand about the different architectures and the different OLAP tools what we have. Right. So any other questions? All right. That's it. Yeah.